This recording is to help you with lesson 4.04, trigonometric functions of any angle. So let's start off with here, and we're going to find the 6 trig functions of the point 7, 24, and 7, negative 24. Well, the first thing we need to do is find r. And r is the square root of x squared plus y squared. So 7 squared is 49, and 24 squared is 576. So we add those together and we take the square root, we get r equals 25. So then basically we just have to find sine, cosine, tangents, and their inverses using the appropriate values here. So sine is y over r plus 24 over 25. Cosecant is the reciprocal of that. Cosine is 7 over 25. Secant is the reciprocal of that. Tangent is 24 over 7. Cotangent is the reciprocal of that. Notice for point Z is still going to be the exact same answers for R. So R is still going to be a positive 25 because you're squaring it. The only thing that's going to change is notice anytime you're dealing with a Y value, so sine or cosecant, you're going to have a negative there. Okay. And tangent as well will be affected by that because we use Y in tangent and cotangent. So just those 4 things should be negative instead of positive. For the next one, again, we're going to use our unit circle here. And the first one, part A, says sine needs to be greater than 0. So where is sine positive? Sine is positive in the first and second quadrants. And then tangent needs to be negative. Well, tangent is negative in the second and the fourth quadrant. So what do they have in common here? Well, quadrant 2 lies in both of those. So theta must lie in quadrant 2. For the next one, cosine is positive in 1 or 4. And tangent is negative, again, in quadrants 2 or 4. So what do they have in common? They have quadrant 4 in common. So that must be where theta lies. All right, next let's find the 6 trig functions. If we know secant equals negative 2 and sine has to be positive. So secant is r over x. Well, if sine is positive, the only way secant can be negative is if cosine is negative. So that means x has to be negative. Okay. And that means r is 2. So if I know r equals 2 and x equals negative 1, we can find y squared using this formula here. So that is the to find y squared, we would do 4 minus 1, which is 3. So y equals the square root of 3. And then we can find our 6 trig functions the following here. Now remember, you don't want to have a negative, or not, you don't want to have a square root in the denominator of your fraction. So there may be times where you have to rationalize your denominator so that no square root actually appears there. All right, next, if possible, find the trig function of the quadrant angle, so secant of pi. So remember, pi refers to the point negative 1, 0. And secant is 1 over cosine. This is how I like to think of it. You can use r over x if you want to by finding r. R is still going to be 1 plus 0, so that's 1. And so you can do it that way, or cosine is negative 1, so you have 1 over negative 1, and you can find it that way as well. So either way is acceptable. All right, it says to solve without a calculator. So what we're going to do is we're going to use the unit circle instead, because I think it's much easier if we use the unit circle. So first of all, let's look at part A. we need to find the radian measure on the unit circle that corresponds to 11 pi over 4. So I'm going to start subtracting 2 pi off. So I subtract 2 pi, and I end up with 3 pi over 4. Now 3 pi over 4 is on our unit circle, and it corresponds to the point negative square root 2 over 2 and square root 2 over 2. So I can easily find the 3 trig functions now. Sine, remember, is your y value, cosine is your x value, and tangent is sine over cosine. So in this one we get -1. For part B, again, that's not on our unit circle, so because it's negative, let's add 2 pi this time. So that would give me -pi over 6. Again, that's not on our unit circle, so if we add another 2 pi, that brings us to 11 pi over 6. 11 pi over 6 is on our unit circle in quadrant 4, and it refers to the point square root 3 over 2 and -1/2. So sine is your y value, cosine is your x value, and tangent is sine over cosine, so that would be -1 over square root 3. Don't forget to rationalize the denominator. So you get negative square root 3 over 3 for tangent. So using your unit circle, I feel, is an easier way to find those 3 values. All right, we want to just know the degree measure for each of these and the radian measure using your unit circle. So cosecant is 1 over sine, so cosecant is not on our unit circle, so let's take the reciprocal of that. 3 over 2 square root 3. Let's rationalize this. So 3 square root 3 over 6 equals square root 3 over 2. So we're looking on our unit circle for 2 places where sine is square root 3 over 2. And sine is square root 3 over 2 at 60 degrees and 120 degrees. And that corresponds to pi over 3 and 2 pi over 3. All right, and then part B, cotangent is -1. That has to be where cosine over sine is -1. And that can only happen at 3 pi over 4 and 7 pi over 4, which corresponds to your 135 degrees and 315 degrees on your unit circle. All right, last you're going to consider an angle in standard position with r equaling 12. As shown in the figure, write a short paragraph describing the change in the magnitudes of x, y, sine theta, cosine theta, and tangent theta as theta increases continually from 0 to 90 degrees. All right, as theta is increasing, the value of x will decrease because your line is going to be going up and up and up, right? So if it's going up here, your x value, which is down along the bottom, gets smaller. Your y value increases because it keeps going higher and higher up. The sine will increase because sine refers to the y, and cosine decreases because cosine refers to your x value. And then tangent will increase because that's sine over cosine until it actually becomes undefined at the absolute top up here.